Good morning, dear students. Welcome back to physics class. Today, I would like to present very significant parts of the chapter Motion in a Plane, which are A. Position vector and displacement vector, B. Velocity vector, and C. Acceleration vector in a plane. The most important part of this chapter is motion in a plane. Let us describe motion of an object in a plane or in two dimensions using vectors. First, let me discuss on position vector and displacement vector. Let r be the position vector of a particle located at a position P in a plane with a reference to the origin O of a rectangular coordinate system, which is shown in given figure. Then the position vector r is mathematically expressed as the vector r is equal to x I cap plus y j cap, which is the expression 1, where x and y are the components of the position vector r along x and y axis, or simply they are the positive x and y coordinates of the object. Suppose the particle P moves along a curve represented by thick line and is at the position P at the time t and position P dash at the time t dash as shown in given figure. From this figure, it is seen that the displacement vector directs from the point P to P dash. Then the displacement vector is represented as vector delta r is equal to vector r dash minus vector r, which is the expression 2, where r dash be the position vector of the particle at the position P dash and r be the position vector of the particle at the position P. We can write the expression 2 in a component form, that is, the position vector delta r is equal to x dash I cap plus y dash j cap minus x I cap plus y j cap, which is equal to delta x I cap plus delta y j cap, where delta x be x dash minus x, that is change in x components values of the position vectors of the particle at two different positions P and P dash at two different times t and t dash respectively, and delta y be y dash minus y, which is the change in y component values of the position vectors of the same particle at two different positions P and P dash respectively. Since the displacement vector is change in position per unit time, then the displacement vector can be mathematically written as delta r is equal to delta x I cap plus delta y j cap, which is the expression 2a. This expression represents the displacement vector of a particle in two dimensions or in a plane. Now, let me discuss on velocity vector in two dimensions. You know about average velocity of an object when it is in motion. What is the average velocity of the object? It is the ratio of its displacement and the corresponding time interval. How can we express the average velocity of the two-dimensionally moving particle in component form, which can be expressed as the average velocity v is equal to delta r by delta t, where delta r be the displacement vector, which is equal to delta x I cap plus delta y j cap whole divided by delta t, where delta x I cap plus delta y j cap be the displacement vector delta r. So, it can be in the form of the average velocity vector v is equal to delta x by delta t I cap plus delta y by delta t j cap, which is equal to delta Vx I cap plus delta Vy j cap, which is the expression 3, where delta Vx is equal to delta x by delta t, which is the s component of the average velocity vector, and delta Vy is equal to delta y by delta t, which is the y component of the average velocity vector. As average velocity of the object is its displacement divided by time interval, that is, average velocity vector v is equal to delta r by delta t, then the direction of the average velocity is same as that of delta r, which is the displacement vector. Then, what should be the instantaneous velocity vector of the same particle, which is obtained by the limiting process of the average velocity of the particle as the time interval approaches to 0. That is, it is the limiting value of the average velocity of the particle as the time interval tends to 0. It can be mathematically expressed as the instantaneous velocity vector v is equal to limit delta t tends to 0 delta r by delta t, where delta r be the displacement vector, which is equal to dr by dt, which is the expression for. It is also read as rate of change of the displacement. Then what should be the change in position of the same particle when the time interval decreases and finally approaches to 0, or delta t tends to 0, it also decreases. Finally, this change also approaches to 0. This limiting process is shown graphically from the figure A to figure D, given below. The path of the moving particle, which is at the position P at time t, is represented by the thick line which is shown in given figure. Let P1, P2 and P3 be the positions of the particle after times delta T1, delta T2 and delta T3. Let delta R1, delta R2 and delta R3 be the displacements of the same particle in times delta T1, delta T2 and delta T3 respectively. The direction of the average velocity v is shown in given figures A, B and C for 3 decreasing values of delta t, that is delta t1, delta t2 and delta t3, where delta t1 is greater than delta t2, which is greater than delta t3. As delta t tends to 0, then delta r also approaching to 0. So, what should be the direction of the instantaneous velocity? Surely, it should be along the tangent to the path, which is shown in figure D. There is a one question. What should be the direction of instantaneous velocity of this moving particle? Its direction is tangential to the path at a point at the instant of time when this value is measured. That is, it is along the direction of the motion of this particle. How can we write this instantaneous velocity vector in its component form, which can be written as instantaneous velocity vector v is equal to limit delta t tends to 0 delta x by delta t I cap plus delta y by delta t j cap, which is equal to limit delta t tends to 0 delta x by delta t I cap plus limit delta t tends to 0 delta y by delta t j cap is equal to dx by dt I cap plus dy by dt j cap is equal to vx I cap plus v by j cap, which is the expression 5, where vx and vy be the x component and y component of the instantaneous velocity vector v. The expression vx is equal to dx by dt, which is the rate of change of x component of the instantaneous velocity v, gives the magnitude of vxi, that is vx, and vy is equal to dy by dt, which is rate of change of y component of the instantaneous velocity, gives the magnitude of vyj, that is vy. Then, what should be the magnitude of the instantaneous velocity v? In figure 2, it has represented the x component and y component of the instantaneous velocity vector v, which are vx I cap and vy j cap, whose magnitudes be vx and vy respectively. From this right triangle, cos theta is equal to adjacent side divided by hypotenuse, which is equal to vx by v. Then vx is equal to v cos theta. And sin theta is equal to opposite side divided by hypotenuse, which is equal to vy by v. Then vy is equal to v sin theta. The magnitude of the instantaneous velocity vector v is obtained by using the Pythagoras theorem. Then hypotenuse square, which is v square, is equal to base square, which is v square, plus altitude square, which is vy square. Then v is equal to square root of v square plus vy square, which is the expression 6. Then what should be the direction of the instantaneous velocity vector v? It is given by the angle theta. As shown in figure 2, the velocity vector or the instantaneous velocity vector makes the angle theta with the x-axis. You know that tan theta is equal to opposite side divided by adjacent side. Here tan theta is equal to vy by vx. Then theta is equal to tan inverse vy by vx, which is the expression 7. Let us examine the acceleration vector of this moving particle. What should be the average acceleration A of this moving particle? It is the ratio of change in velocity to the time interval, which is represented by vector A is equal to vector delta v by delta t, where delta v be the average velocity vector is equal to delta vx I cap plus vy j cap whole divided by delta t is equal to delta vx by delta t I cap plus delta vy by delta t j cap is equal to delta ax I cap plus delta ay j cap, which is the expression 8, where delta ax and delta ay be the x component and y component of the average acceleration vector delta a. What is instantaneous acceleration? It is the limiting value of the average acceleration as the time interval approaches to 0. Its mathematical form is instantaneous acceleration a is equal to limit delta t tends to 0 delta v by delta t is equal to dv by dt, which is the expression 9. When it is written in its component form, the instantaneous acceleration vector a is equal to limit delta t tends to 0 delta vx by delta t I cap plus delta vy by delta t j cap, which is equal to limit delta t tends to 0 delta vx by delta t I cap plus limit delta t tends to 0 delta y by delta t j cap is equal to dvx by dt I cap plus dvy by dt j cap is equal to ax I cap plus ay j cap, which is the expression 10, where ax and ay be the x component and y component of the instantaneous acceleration vector a. The expression ax is equal to d by dt of vyx gives the magnitude of ax I cap, that is ax, and the expression ay is equal to d by dt of vy gives the magnitude of ay j cap, that is ay. Ax is also written as d square x by dt square, which is second derivative of x component of the displacement vector, that is d by dt of dx by dt, and ay is also written as d square by dt square, which is the second derivative of y component of the displacement vector, that is d by dt of dy by dt. You should understand that these are similar to the differentiating of the corresponding component of instantaneous velocity vector with respect to the time t. The figures A to D show that the change in velocities of the same particle when the time interval decreases and finally approaches to 0, that is delta t tends to 0. This change in velocity also decreases and finally approaches to 0. This limiting process is shown graphically from the figure A to the figure D. In the limit delta t tends to 0, the average acceleration becomes the instantaneous acceleration, which is shown in figure D. This slide also shows the average acceleration for 3 time intervals delta t1, delta t2 and delta t3, where delta t1 is greater than delta t2, which is greater than delta t3. From the figures A to D, P represents the position of the object at time t and P1, P2, P3 positions after time delta t1, delta t2, delta t3 respectively. The velocity vectors at the points P, P1, P2 and P3 are also shown in figures A, B and C. Let V be the velocity vector at the point P and V dash be the velocity vector at the point P1 or P2 or P3. Let delta V be the average velocity in each case. You have to examine the figures A to C. In each case of delta t, delta v is obtained by using the triangle law of vector addition. You should note this point. By the definition, the direction of average acceleration is the same as that of delta v, which is the average velocity. Then we see that as delta t decreases, the direction of delta v changes and consequently the direction of the acceleration changes. When time interval delta t tends to 0 as shown in figure D, the acceleration, which is instantaneous acceleration, has the direction which is given in figure D. From this point, you have to understand as the direction of the average acceleration is along the direction of the average velocity, and by doing the limiting process which result to decrease the magnitude of the average velocity and also change in its direction. So, the average acceleration whose direction is also changes with respect to change in direction of the average velocity. And finally, the acceleration is the instantaneous acceleration which makes certain angle with respect to the direction of the instantaneous velocity v. So, you should examine the figure D again. You should note that in one-dimensional motion, the velocity and the acceleration vectors of an object are always along the same straight line, either in the same direction or in the opposite direction. However, for motion in 2-dimension or 3-dimension, the velocity and the acceleration vectors may have any angle between 0 degree and 180 degree between them. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay. Thank you. Have a nice day.